Weak legs, back pain, and low energy are usually discussed as if they belong to different chapters of health. Each assign its own cause, treatment, and explanation, yet the body does not operate in this compartmentalized way. Biology favors efficiency and integration, meaning that systems are designed to work together, share information, and respond collectively to change. When something begins to drift out of balance, the effects rarely stay confined to one area. Instead, they ripple outward, appearing as multiple symptoms that seem unrelated on the surface, but are deeply connected beneath it. The human body relies on constant feedback to regulate posture, movement, and endurance. Sensors in muscles, joints, and organs send continuous information to the brain about load, position, and internal state. When this feedback becomes inconsistent, perhaps due to chronic stress, inflammation, poor circulation, or metabolic strain, the brain adjusts output to maintain control. Legs may feel weak because force reduction is intentionally reduced, not because strength is gone. The back may become painful because stabilizing muscles increase tension to protect balance. Energy declines because cells are being instructed to conserve rather than expend. This interconnected response can be confusing, especially when medical tests focus on isolated structures. A scan may show no severe damage in spine. Muscles may appear intact, and blood work may fall within normal ranges, yet the person still feels compromised. What is often missed is that coordination, timing, and adaptability are difficult to measure, even though they are central to how the body feels. The system may be functioning, but at a guarded level, prioritizing safety over performance across multiple regions at once. Over time, this guarded state becomes familiar. Movement patterns subtly change, posture adapts, and energy is rationed without conscious awareness. The legs take shorter steps, the back avoids certain ranges, and daily tasks require more effort. These adjustments are intelligent, designed to reduce risk, but they come at the cost of comfort and vitality. Because the same underlying signals drive all of these changes, addressing only one symptom rarely creates lasting improvement. Understanding these symptoms as expressions of a shared imbalance reframes the entire experience. Instead of asking why the legs are weak or the back hurts, the more useful question becomes what conditions are causing the body to hold back across the board. When circulation improves, stress decreases, nutrition supports cellular function, and movement restores confidence, the system begins to release its guard. Strength, comfort, and energy return together, not because they were fixed separately, but because the body no longer needs to express the same message in multiple ways. Strength and movement are often misunderstood as qualities that belong solely to muscles, as if muscle fibers themselves decide when to contract, how much force to produce, and how long to sustain effort. But biology tells a far more interconnected story. Every simple action, from standing up to taking a step, depends on a continuous conversation between the brain, the spinal cord, peripheral nerves, blood vessels, and the microscopic machinery inside each cell. When this conversation is clear and well supported, movement feels natural and effortless. But when the signals become distorted or delayed, the body begins to move with hesitation, stiffness, and unnecessary strain. Nerves act as messengers in the system, translating intention into action through electrical impulses. Yet these impulses are highly sensitive to their environment. Inflammation, nutrient deficiencies, poor circulation, or chronic stress can subtly interfere with nerve signaling long before any dramatic damage appears on scans. Muscles may still be present and structurally intact, but without precise neural input, they lose coordination, firing out a sequence or with reduced strength, which the body interprets as weakness. This is why someone can feel physically fragile despite having normal muscle mass, because strength is not only about size but about timing and communication. Blood flow adds another essential layer to this process, delivering oxygen and nutrients while clearing metabolic waste. When circulation is compromised, even mildly, muscles and nerves begin to operate in a state of quiet shortage. They can perform, but at a cost, generating tension and fatigue more quickly. Over time, the body adapts by redistributing effort, asking some muscles to work harder while others disengage, creating imbalances that are often felt as stiffness in the back or instability in the legs. These adaptations are not random. They are survival strategies designed to keep movement possible under less than ideal conditions. At the cellular level, movement is powered by energy production that must respond instantly to demand. Mitochondria adjust output based on signals from nerves and hormones, and when these signals are disrupted, energy becomes inconsistent. Muscles then rely on emergency pathways that produce force but also generate fatigue and discomfort. The person feels this as heaviness, as if the body is working harder for the same outcome. Because it is, the coordination between systems has lost its efficiency, turning simple motion into effort. Understanding strength through this integrated lens shifts the focus away from isolated fixes and toward restoring harmony between systems. When communication improves, circulation supports demand, and cells regain metabolic flexibility. The body naturally reorganizes itself towards stability and ease. Weakness fades not because muscles were forced to change, but because the entire network learned to speak clearly again. Back pain and leg weakness are often approached as mechanical problems, as if the body were a rigid structure that simply wears out with time. Yet the nervous system tells a different story, one rooted in protection rather than damage. Pain, in this context, is not merely a signal of injury, but a sophisticated alarm designed to limit movement when the brain senses instability, uncertainty, or overload. When signals coming from muscles, joints, or internal systems become inconsistent, the nervous system responds by increasing tension, reducing range of motion, and altering movement patterns to prevent what it perceives as potential harm. This protective response can develop quietly, long before a person becomes consciously aware of it. Subtle changes in posture, breathing, or gait begin as temporary adjustments, but when the underlying stressor persists, these adjustments solidify into habits. Muscles surrounding the spine may remain partially contracted, not because they are strong, but because they are guarding. The legs may feel weak or unsteady, not due to true loss of strength, but because the brain is limiting force output to maintain control. In this way, pain and weakness become linked expressions of a system prioritizing safety over performance. The nervous system constantly evaluates information from inside the body, integrating sensory input with past experiences and perceived threats. Chronic stress, fatigue, inflammation, or metabolic strain can all heighten the sense of threat, even in the absence of visible injury. When this happens, the threshold for protection lowers, meaning the body reacts defensively to movements that were once effortless. The back becomes a focal point because it sits at the crossroads of balance, load transfer, and movement coordination, making it a natural area for the nervous system to restrict when confidence and stability declines. Over time, protective tension alters how forces are distributed through the body. Instead of movement flowing smoothly across joints and muscles, stress concentrates in specific areas, often the lower back or hips. This concentration creates discomfort, stiffness, and fatigue, reinforcing the brain's belief that the area is vulnerable. The legs respond by reducing power output, favoring caution over strength, which further limits movement and increases reliance on rigid postures. The cycle sustains itself not through structural failure, but through ongoing protective signaling. Seen through this lens, pain is not the enemy but a message that the nervous system is asking for reassurance. It seeks clearer signals of stability, sufficient energy availability, and reduced internal stress. When these needs are met, the system gradually relaxes its guard, allowing muscles to lengthen, strength to return, and movement to feel safe again. The body does not need to be forced out of protection. It needs to be shown that protection is no longer necessary. Low energy is often described as a feeling, but biologically it is a state, one that reflects how well the body is able to convert resources into usable power at the cellular level. Every movement, every thought, every heartbeat depends on a steady supply of energy generated inside mitochondria, the small structures within cells that respond continuously to demand. When these systems are supported, energy rises and falls naturally across the day. But when they're stressed, the body shifts into conservation mode, quietly prioritizing survival over vitality. Mitochondria are exquisitely sensitive to their environment. They respond not only to nutrition and oxygen, but also to hormonal signals, inflammation, and psychological stress. Chronic pressure, whether physical or emotional, sends repeated messages that conditions are unsafe or unpredictable. In response, mitochondria reduce output, not as a failure, but as a protective adjustment. Energy production becomes less efficient, favoring short-term fuel pathways that are easier to access but more draining over time. The result is a background sense of fatigue that rests alone, does not fully resolve. When energy becomes limited, the body must decide where to spend it. Large postural muscles, especially those in the legs and back, require constant energy just to maintain upright posture and balance. These muscles are active even when we believe we are resting, making subtle adjustments to keep us stable. As energy availability drops, these areas are often first to feel heavy, weak, or achy, not because they are damaged, but because they are being asked to do essential work with insufficient fuel. This energy rationing changes how movement feels. Actions that were once automatic begin to require conscious effort. Standing up, walking, or climbing stairs may feel disproportionately tiring because the body is compensating for reduced cellular output. Muscles rely more heavily on emergency energy systems that generate force quickly, but produce metabolic byproducts associated with discomfort and fatigue. The nervous system senses this inefficiency and responds by limiting movement intensity, reinforcing the feeling of low energy and physical reluctance. What makes this process particularly challenging is its invisibility. Standard tests may appear normal because the issue is not a lack of structures, but a decline in adaptability. Cells are still functioning, just at a reduced capacity, shaped by long-term patterns rather than acute disease. This is why pushing harder often worsens fatigue, while thoughtful restoration can gradually reverse it. When stress is reduced, nourishment improves, and signals of safety return, mitochondria regain flexibility, increasing output without strain. Energy, in this sense, is not something to be forced or extracted, but something that emerges when conditions allow it. As cellular systems recover their ability to meet demand efficiently, the body stops rationing, strength returns to the legs, the back relaxes, and movement begins to feel lighter again, not through effort, but through restored balance. The human body is often judged harshly when discomfort appears, as if pain and weakness were signs of failure or decline. Yet from a biological perspective, these experiences are better understood as messages shaped by intelligence rather than breakdown. Every sensation the body produces has a purpose rooted in survival, adaptation, and communication. Symptoms arise not to punish, but to inform, guiding attention toward conditions that have drifted out of balance. When weakness, pain, or fatigue persist, it is rarely because the body has lost its capacity to heal, but because it is still waiting for the right signals to begin that process. This understanding invites a shift in how health is approached, moving away from control and toward collaboration. The body responds not only to what we do, but to how consistently and respectfully we do it. Nourishment, for example, is more than calorie intake. It is information delivered to cells about safety and abundance. Regular movement, when matched to the body's current capacity, communicates trust and stability to the nervous system. Rest, often underestimated, is not laziness, but an active biological state in which repair, learning, and recalibration take place. From this integrated perspective, healing is not about silencing symptoms, but about changing conditions that produce them. When stress hormones remain elevated, circulation is compromised, and cellular energy is restricted, the body stays in a guarded state. In that state, pain persists because protection feels necessary. When these pressures are gradually reduced, the nervous system begins to update its internal map, reassessing what is safe. Muscles release unnecessary tension. Coordination improves, and strength returns without being forced, reflecting a system that feels supported rather than threatened. Curiosity plays a critical role in this process. When individuals become interested in how their bodies respond to sleep, food, movement, and emotional load, they begin to notice patterns rather than isolated events. This awareness fosters compassion, replacing frustration with understanding. The body is no longer an obstacle to overcome, but a partner offering feedback. Each signal becomes an opportunity to adjust rather than a problem to suppress. Over time, this relationship reshapes health outcomes. Small, consistent changes create an environment where biological systems can synchronize again. Circulation improves, energy production stabilizes, and neural signaling becomes clearer. Strength and comfort emerge as byproduct of coherence rather than targets achieved through force. The body, when given what it needs, does not resist healing. It moves toward it naturally, expressing resilience not through perfection, but through its remarkable ability to adapt when it is finally understood.